So the members of the Vienna Circle look out into the world, and what they see is this enormous surge in mathematical and logical knowledge. They see these tremendous paradigm-shaking movements in the physical sciences. And they say, we can look at these and glean the insights out of these developments, figure out what's going on with these things, synthesize a philosophy of science. And so they seek to create a foundationalism for empirical knowledge by creating a hierarchy of axiom system whereby all science is reduced to physics and all theory reduced to observation language. This would provide an external epistemological justification for science rooted in the certainty of direct experience and intuition, akin to the sorts of projects that are going on in mathematics. Naturally, this isn't how science actually proceeds. Rather, it's a rational reconstruction, a conceptual house cleaning that they will do after the scientists have done their basic work. Like our mathematical counterpart, the positivist project has these two aspects, conceptual studies and doctrinal studies. Using the concepts of immediate experience, that is, of the concepts of our observational language, of logic, and of set theory, they seek to define all theoretical vocabulary in this very strong sense of reducing it to those observational terms. They want to make all obscurity of the talk of the physical world as clear as the talk of immediate experience. And they initially adopt the verificationist theory of meaning. No sentence is meaningful if you cannot articulate the conditions for its verification. And once you articulate those conditions, the operation by which you would test to see if it's true, you have exhausted its meaning. When it comes to doctrinal studies, they seek to derive all the laws of science from immediate experience. Now, you're going to have to derive the laws of even the most basic science like physics from experience through inductive logic, but also through the reductive analysis of the theoretical concepts, observation language concepts, in conceptual study. So you figure out how to operationalize all your physical parameters, and you perform your experiments. You crank your data through the giant inductive logic engine, and out pops your universal generalization around which you can construct your axiom system for that particular domain. So the structure of science then, from sociology on down, would look something like this. We've got this nested set, this hierarchy of axiom systems, where the science of any system at any level of description is an axiom system with a set of central laws and a set of operation principles that tie those laws to the world. Each science that is above physics will be reduced to physics by showing how the theoretical terms of that science can be reduced either directly to observational language or to the sciences beneath it. Thus, theoretical terms get cashed out in terms of more and more basic terms, and ultimately in terms of the observational language itself, the language of ordinary objects. Unfortunately, even as Carnap is finishing the Aufbau, the project in mathematics is coming to its final death throes. Hilbert's dream that mathematics will be cashed out as a formal system is being destroyed by this gentleman over here. This is Kurt Gödel, who his family used to call as a boy Mr. Y, because he always wanted to know why. Gödel showed that any formal system rich enough to express mathematics is either inconsistent or it's incomplete. If it's inconsistent, you can prove anything. If it's incomplete, there are truths expressible in the system that you can't prove within the system, and hence your axiomatization will always either be an inconsistent and pointless axiomatization or an incomplete axiomatization in which you may set out to prove a problem and never be able to do it. Hilbert wasn't ready to give up just yet, though. He said, look, even if we have these incomplete axiom systems, because of course we're not going to fall for the inconsistent ones, even if we have these systems where there are things that can be expressed as truths that we cannot prove, if we can determine ahead of time that we can't prove that, then we can avoid wasting our lives trying to prove things that can't be proven in our system. And this got phrased in terms of a lecture that he given all the way back in 1900, where he outlined 23 problems, at least, that he thought young mathematicians ought to look at. And one of them was how to solve a particular kind of equation, the Diophantine equation. But it was a general problem now. It was a problem of whether or not you can decide ahead of time whether something is in fact solvable in your system. But the end was nigh, because first Alonzo Church in 1936 and then Alan Turing in 1937 decisively proved that you cannot do that. You cannot come up with a general means of determining ahead of time whether or not a problem was decidable within your axiom system. And hence, the axiom systems that you would create would be either inconsistent or they would be incomplete. And incomplete in ways that you could not get around. You couldn't decide ahead of time whether or not a project within this system was in fact one that you could accomplish or one that you would waste your entire life on. And so we'll see the second half of this project to axiomatize mathematics emerges in the very beginning of the 1930s. Gödel publishes On Formally Undecidable Propositions of Principia Mathematica and Related Systems. Church publishes An Unsolvable Problem of Elemental Number Theory, and Turing publishes On Computable Numbers with an Application to the Einzigem Problem. And at this point, the prospects of this project within mathematics just evaporate. But what about our logical empiricists? Well, obviously, if the mathematicians are having such problems, you can only imagine what the philosophers are dealing with. And Quine sums it up in the paper by saying, not even the combination of the verificationist theory of meaning or the contextual definition or the weakening of the goal to implicational definitions can overcome the fact that the typical statement about bodies has no fund of experiential implications it can call its own. The world is fundamentally ambiguous. What about the doctrinal studies? Here, Quine tells us that the Humean predicament is the human predicament. The most modest of generalizations about observable traits will cover more cases than its utterer can have had occasion to actually observe. So we'll end this lecture module here, and then we'll pick up with the final part of the lecture next module.